So we're going to continue, students, in part 2 in complex number video. We said before that a plus ib into a minus ib is a squared plus b squared. So the product of a complex number times its conjugate is a real number equal a2 plus b2. Let us take some examples where I'm going to use this one. Suppose you want to divide complex by complex. I have 2 over 2 minus 3i. Everything is complex. Even 2 is called complex. It's written as 2 plus 0i. So what do? To find the complex number that I have here, I must get rid of the complex down. So I multiply down by the conjugate because this is the only way to get rid of the complex. So if I have 2 minus 3i, I multiply by the conjugate 2 plus 3i. Not to change anything, I multiply it up. So what do I get? 4 plus 6i over a minus ib into a plus ib is a squared plus b squared. A squared plus b squared, so this is 4 plus 9. So 4 plus 9, it will give me 4 over radical 13 plus 6 over radical 13i. So this division will lead me to a complex number whose real part is 4 over 13 and imaginary part 6 over 13. If I have this division, same story. I multiply by the conjugate of 3 plus I, which is 3 minus I. Since I have in denominator a complex number, not to change anything, I write it up. I expand 2i times 3 is 6i. 2i times minus I is minus 2i squared, but I squared is minus 1, so plus 2. A plus ib into a minus ib is a2 plus b2. It means 9 plus coefficient of I here is 1. So 9 plus 1 is 10. So I have 2 over 10, which is 1 over 5, plus 6 over 10, which is 3 over 5i. I want to tell you one thing you must be careful about. When you want to multiply by the conjugate, please keep the real part to be positive always, because if you're going to keep it as negative and you're going to multiply by the conjugate, instead of having a squared plus b squared, you're going to get minus a squared minus b squared. Not to do a mistake, please bear in mind, anytime you have a complex number and you want to multiply it by the conjugate, convert everything opposite so that the real part here will be, it was minus, it will be plus. So by multiplying numerator by minus 1, denominator by minus 1, so opposite of 2i minus 2i, minus 1, 1, minus 3, 3, I is minus I. Now I multiply by the conjugate of 3 minus I, which is 3 plus I. I have this calculation, it's written up. If you can see it, you can do it step by step, over a2 plus b2. So I have this complex number at the end. Factorize, we talked about it in the first video. X squared minus 9 is x minus 3x plus 3. You already know this in elementary classes. Here it is, we're factorizing in the real, not in complex. But however, if you have x squared plus 9, you all know x squared plus 9 is of the form a2 plus b2. So I write it as a minus ib into a plus ib. So x minus 3i into x plus 3i. If you equate it to 0, you have x equal 3i or x equal minus 3i. Another example, suppose you want to factorize this one. First of all, it's of the form a2 plus b2. And a2 plus b2, we know it's a minus ib, 25 will be 5i, into a plus ib. Here you have plus, not minus, plus. So if you equate it to 0, x plus 1 minus 5i is 0, and x plus 1 plus 5i is 0. You're going to get x equal minus 1 plus 5i, and x equal minus 1 minus 5i. Okay, if you want to solve it in another method, you can put square. I'm not going to write it. Equal to minus 25. If you remove the square, you all know you're going to get without square equal plus or minus radical minus 25, and plus or minus radical minus 25, it will be plus or minus 5i. So what will be x? So x will be minus 1 plus radical 5, or minus 1 minus, sorry, minus 1 plus 5i and minus 1 plus 5i. Equation of second degree. We used to have, when we have delta less than 0 in equation of second degree, no real roots, impossible. However, because delta is negative, we can solve it in the complex. And when you're going to solve it in the complex, since we have radical of minus, we put I and absolute value for radical delta. So let us take examples. Suppose I want to solve this equation of second degree. You all know that a is 1, b is minus 4, and c is 5. We do delta, which is b squared 16 minus 4ac minus 4 times 1 times 5. So 16 minus 20 is minus 4, less than 0, so 2 complex root. So I have two roots. The first one is minus b4 plus or minus radical of minus 4. But radical of minus 4 is a complex, so I write it as I radical 4, and I radical 4 is 2i, so I have two roots. And if I want to factorize it, you know this is the formula. You took it in grade 9 and 10 of factorizing. A is 1. You take these two to the first side. So you're going to get x minus 2 plus I, the first factor, and x minus 2 minus I, the second factor. Another example, same story, b squared minus 4ac, b is 2 squared 4, minus 4 times 1 times 10. So you have minus 36, minus b plus or minus radical delta over 2a. Because I have square root of negative numbers, so it's written 6i. I have these two roots. And if I want to factorize it and bring these two to that side, the first factor will be x plus 1 plus 3i, and the second one x plus 1 minus 3i. When two complex numbers are equal, two complex numbers are equal when real equal real and imaginary equal imaginary. So if you have a plus ib equal a prime plus ib prime plus ib prime, these two are equal when a is a prime and b is b prime. So why I'm going to use this? Let us see this problem. The question here is find a and b so that these two are the same. The first one equal to the second. This is a complex number and this is another complex number. So real equal real. The real is the things without I. Here I have 2a plus 7. The real in the second equation is 2. I equated. A is minus 2.5. Imaginary here is minus 3. Coefficient of I minus 3 minus 3b equal to minus 3. So if you solve it, plus 3 to the other side, 0 over minus 3 is 0. Another example, find also a and b so that these two are equal. 0, it means I can write it as 0 plus 0i. I expand 2a minus 4i minus 21ib plus 2 minus 4 plus 2i, etc. equal to 0. So here the real 2a, the things without I, minus 14 minus 4 is minus 18 equal to 0, so a is 9. Here the things with I, you have minus 4 and plus 2. So this is minus 2. Let me correct it. This is minus 2. So minus 2 minus 21b equal to 0. So b will be minus 2 over 21. Okay. More problem. In this question, the question is, we need to find, we still have 2 minutes. We have to find a complex number z satisfying this equation. So what do? We expand 2z minus 6iz plus 12i squared plus 12i squared is minus 12 equal 2 minus 3iz plus 4z minus I. I need to find z, so I put everything with z in the first part. Everything with z, this is here z, here z, here z, here z, and everything without z to the other part. So it will be 2 plus 12 minus I to the other side, and everything with z on the first part. So 2z minus 4z is minus 2z, minus 6iz plus 3iz is minus 3iz, 14 minus I, so I put z in factor, minus 2 minus 3i equal 14 minus I, so I have this expression. You know, I cannot keep it this way, I must multiply by the conjugate. But you realize that coefficient of the real is negative, so I put everything opposite, minus 14 plus I over 2 plus 3i times the conjugate 2 minus 3i. If you distribute of minus 14 times 2 minus 14 times minus 3i, I times 2, I times minus 3i over a2 plus b2. What's a2 plus b2? 4 plus 9. I will get that answer. So now I'm going to see you in video number 3. I'm going to stop here and we're going to continue in video number 3.